Hi, I'm Glenn.
And I'm Brent.
And we're the Penumbra Brothers.
We focus on you.
Hello, it's Glenn again. Welcome back to the Penumbra Brothers series on the ARRT exam content specifications. In this episode, we're going to cover radiation protection part C. Kind of separated out from the last because it's kind of its own thing. Now, the ARRT content specifications list the inverse square law, but it does not list the direct square law or the exposure maintenance formula. We're going to cover that anyway. That's why this one needs to be by itself. So what the inverse law tells us is it gives us how much exposure changes at different distances from the source if your technical factors stay the same. Specifically, the inverse square law states the intensity of the X-ray beam is inversely proportional to the square of the distance. Perfectly clear the first time you're hearing it, right? Maybe not. So what that does tell us is the intensity from one point, if we change our distance from the source to the detector, how much that changes. It's kind of like a flashlight. If we hold it relatively close in this circle, and say we have 1,000,000 photons in there, we pull the flashlight back to the second circle. The second circle is 4 times the area. So on our inside circle, we have 4 times less photons than the first exposure. So that tells us the further we get from the source, the less radiation dose that we are going to receive. That is due to divergence of the beam, and at closer distances, more intense, further away, less intense, just like that flashlight. You can calculate the radiation dose at different distances. Now the formula listed here is my own formula I've been using for a couple of decades. You can use that old formula where you inverse and multiply and do all that other stuff and sprinkle fairy dust to make the formula work. You can just use this formula. So the intensity that you start with multiplied by the first distance squared divided by the second distance squared, that's it. Now you have your answer for your second intensity. Now there's also a little cheat code. Normally we're going from 40 to 72 inches or 72 to 40 inches. So with these specific distances only, if you're going from 40 to 72 inches, you are reducing the intensity. So your intensity specifically reduces in a square area by 3.24. So you can take your intensity and divide by 3.24. The opposite is true. If you're going from 72 inches to 40 inches, then your intensity increases by 3.24, so you can just multiply. It works really great, super easy. Going on to the direct square law, or the exposure maintenance formula. So the direct square law states that to maintain radiographic exposure when changing SID or your distance, the MA must be changed directly proportional to the square of the distance. Again, perfectly clear the first time you're hearing it. So what this tells us is, now remember the inverse square law. If we change our distance, the beam is less intense. So to correct that, we have to use more mass to get the same intensity in our specific exposure area. It's completely the opposite. So again, you can use that formula that's normally taught where you inverse and multiply and do all this sprinkle fairy dust, or you can use the formula I've been using for a couple of decades. Your first mass multiplied by your second distance squared divided by your first distance squared will give you the mass you need, whether you're increasing or decreasing distance. Simple, easy, much easier to use formula. Is there a cheat code for this one? Sure there is. So on this one, it's the exact opposite. Again, we normally change from 40 to 72 inches or 72 to 40 inches. If we're changing from 40 to 72 inches, the exposure you need to make sure that you have the same exposure at that 72 inches is you multiply your mass times 3.24. Super easy. Same thing, if you're going from 72 inches to 40 inches, then you divide your mass by 3.24. Just that easy. So keep tuned in for more videos. We're going to have a lot of them coming out very soon.